Hello guys, welcome back to a new video. Now in this video, we will be solving section 3 from chapter 3. The first question, it says, the time required to fill a bucket with water from a certain garden hose is 30 seconds. If you basically decrease the cross-sectional area of this hose by covering the hose nozzle with your thumb, how long does it take to fill the bucket this time? It's going to exactly take the same amount of time because the flow rate never changes. The flow rate is equal to V divided by delta T. This never changes, and it is only the speed at which the fluid is flowing that changes. Okay, maybe it's going faster this time when you cover the hose with your thumb, but the flow rate never changes. Okay, so it would still take 30 seconds no matter what you do. Water at a pressure of 3 times 10 to the power of 5. So you have P1, guys, which is equal to 3. Let's write the givens first. So you have 3 P1 is equal to 3 times 10 to the power of 5 Pascal. Okay, flows 3 horizontal pipe at a speed of 1 meter per second. This is V1, which is equal to 1 meter per second. The pipe narrows to 1/4 its original diameter. So D2, guys, we can say is equal to 1/4 D1. Okay, I'll come back to this one and I'll explain how do we find area with this one. Find the following. A, it says, what is V2 equal to? Okay, as you remember from the continuity equation, A1 is equal to V1. A1 multiplied by V1 is equal to A2 multiplied by V2. We want to find what? We want to find V2, so divide this one by A2 and divide this one by A2. A2 cancels, then V2 is equal to A1 multiplied by V1 divided by A2. Now guys, do I have A1? No, I don't have A1. Do I have A2? No, I don't have A2 too, but we could do something and try to cancel this A1. Okay, now guys, for this one, remember that area is equal to pi r squared. Okay, and radius is equal to what, guys? Radius, as you know, is equal to diameter divided by 2. So instead of writing this one, I can say area is equal to pi multiplied by diameter divided by 2 all squared. Then area is equal to what? Pi. Then this one and this one, they have what? Diameter squared divided by 4. As you see, guys, from this equation, you can see that area is proportional to the square of diameter. Okay, meaning if diameter 2 is equal to 1/4 of diameter 1, let's put it in this equation. Forget about this 4 and forget about this pi. Okay, area is equal to diameter squared. Okay, so let's put this diameter here. We say 1/4. This is what, guys? This is D1. So all of it squared, you have what? You have 1/16, guys. Okay, you have 1/16. So this is what, let's say this is A2, sorry. This is A2 because we have diameter 2 here. So diameter, guys, is, or area we can say, is proportional to the square of diameter. So here, guys, diameter 2 is equal to 1/4 of diameter 1. So area will be what? Area 2 will be 1/16 of area 1. Okay, how do I get this 1/16 from the equation, guys? You see, diameter is proportional, or area is proportional to the fourth of the square of the diameter. Now guys, let's plug in the values that we have. By the way, let's write this one here. Area 2 is equal to 1 over 16 area 1. Okay, now let's plug in the values that we have. Area 1, V1 is equal to what? Is equal to 1 meter per second. Then guys, A2 is equal to what? Is equal to 1 over 16 A1. You see A1 cancels. Then multiply this and take this one to up. So you have V2, which is equal to 16 meter per second. This is what, guys? This is the second velocity, V2, okay? Or the flow in which the flow speed in the narrow section. Part B of the question says the pressure in the narrow section, okay? The pressure in the narrow section. So it needs what? It needs P2. P2 is equal to what, guys? We had V1, which is equal to 1 meter per second. We found V2, which is equal to 16 meter per second. This time we need density 2. Density is equal to, because it's water, so 1 times 10 to the power of 3 kilogram per meter cubed. Then P2 is equal to what? Because it's a pipe and it's horizontal, you don't have height too, and we don't know the height. In a question, if you don't have the height, always use the horizontal equation that you had. So P1 plus 1 over 2 rho V1 squared, which is equal to P2 plus 1 over 2 rho V2 squared this time. And then this is horizontal. I could just write horizontal. Now guys, we need to find what? We need to find P2. You can take this one here, okay? And this one becomes what? This one becomes P1 plus 1 over 2 rho V1 squared minus 1 over 2 rho V2 squared is equal to P2. Okay, now you need to do what? You need to take these two, this one, 1 over 2, and rho as the common. So you have P1 plus 1 over 2 rho V1 squared minus V2 squared, okay, is equal to P2. Okay, you can write it in another way. You can take this P2 to the other side and take this one to the other side. It doesn't matter how you write it, it's the same thing. Now let's plug in the values that we have. P1 is equal to what, guys? It is equal to 3 times 10 to the power of 5 plus 1 over 2 multiplied by 1 times 10 to the power of 3, which is the density of water. Then you have V1, which is equal to what? Which is equal to 1 meter per second squared, minus, which is equal to 1 meter, sorry. So this one will be 1 squared, minus V2 is equal to what? We found V2, which was equal to 16, then 16 squared 2 is equal to P2. Calculate all of this, and P2 is equal to 1.72 times 10 to the power of 5 Pascal. Okay, this is the pressure in the narrow section. We have question 3. The water supply of a building is fed through a main entrance pipe that is 6 centimeters in diameter. So this is D1. Sorry, this is D1, which is equal to 6 centimeters. Then you can divide this by 2 and you get radius 1, which is equal to 3 centimeters. Then you should change this to meter. You get 0.03 meter. Okay, a 2 centimeter diameter faucet tap positioned 2 meters above the main pipe fills a 2.5 times 10 to the power of minus 2 meter cubed container in 30 seconds. Now, diameter 2 is equal to 2 centimeters. Then divide this by 2, you get the second radius, which is equal to 1 centimeter. Then this is equal to, you should change this to meter, 0.01 meter. This is what? This is the second radius. Sorry, this is the second radius. And you have volume, which is equal to 2.5 times 10 to the power of minus 2 meter cubed. Okay, then you have delta t, which is equal to 30 seconds. Okay, part B of the question says, what is the speed at which the water leaves the faucet? I think you forgot something. Yeah, I forgot height 2. h2 minus h1 is equal to 2 meters. Part A of the question says, what is the speed at which the water leaves the faucet? So A, it needs what, guys? A, it needs V2 is equal to what? Okay, as you remember, V2 was the area, or was the place that the water was leaving. Okay, so you regard this as V2. Now, guys, we have the equation for flow rate, okay, which was A V, which was equal to volume divided by delta T. I need to find velocity, the second velocity, so this one is V2 and this one is A2, okay? Then divide all of this by what? By A2, and divide this one by A2. Cancels. Then from this equation we get V2, which is equal to, and then you can just bring this up. You have V divided by A2 multiplied by delta T. Then, guys, volume is equal to 2.5 times 10 to the power of minus 2 divided by area is equal to what, guys? Is equal to pi r squared. So I can write pi multiply by r is equal to what? This is the second radius, so 0.01. Yes, as you can see here, 0.01 all squared, then multiplied by time, which is equal to 30 seconds. And you get 2.65 meter per second, or you can just basically write 2.7 meter per second. This is part A of the question. Then we have part B of the question, which says, what is the gauge pressure in the main pipe? Because we have height, guys, so write all the equation that you have, okay? Let's write the equation. We have P1 plus 1 over 2 rho V1 squared plus rho GH1, which is equal to P2 plus rho, 1 over 2 rho V2 squared this time plus rho GH2. Okay, now it needs gauge pressure. Let's see if we have everything, because it's asking for gauge pressure. We should say that P1 minus P2 is equal to what? Okay, or you can just simply remove one of the P's and then it will be the same. So you should move this. Oh, let's just first check if we have everything. Okay, do we have density? Yes. Do we have the first velocity? No, we don't. Okay, we don't have the first velocity. We found the second velocity, which is equal to 2.7, but we don't have the first velocity, guys. Let's find the first velocity. Okay, the first velocity is equal to what? Is equal to A1 V1, which is equal to A2 V2. Okay, you need to find V1. Okay, so divide this one by A1 and divide this one by A1. A1 cancels. V1 is equal to A2 multiplied by V2 divided by A1. Okay, so this is equal to what? Pi R2 squared multiplied by V2 divided by what? Divided by pi R1 squared. Pi is the same, so they cancel. So you have R2 squared V2 divided by R1 squared. This is V1. Then, guys, this will be what? Radius, the first radius is equal to, the second radius is equal to 0.01 squared, then multiplied by V2, which is equal to 2.7, divide by what? Divided by 0.03 all squared. Okay, you should get how much? You should get 0.29 meter per second or 0.3 meter per second. Okay, this is what, guys, this is V1. Now we found V1 too. Now, because we need P1 and P2, let's take this P2 here and take all of this here, all of this. Okay, so you have what? You have P1, you have P1 minus P2 is equal to 1 over 2. Let's just delete this. Yes, this is better. Yes, 1 over 2 rho V2 squared plus rho GH2. Okay, minus, plus rho, minus 1 over 2 rho V1 squared minus rho GH1. Okay, now as you can see here, I have density as the common, so I can just basically take density as the common thing between them. And as you can see here, gravity here is common between these two. I can take the gravity as the common, and this one becomes H2. Okay, so this one, the final equation will be like this. Final equation will be like this: P1 minus P2 is equal to, take density as the common, then this one remains alone, 1 over 2 V2 squared. Then you have what? You can just get this one here. So this becomes minus 1 over 2 V1 squared. Okay, then plus this one will be what? Take G as the common, so H2 minus H1. Okay, because we have height as H2 minus H1, so all of it is equal to 2 meters. Careful. Okay, so these two should always be together, H2 minus H1. Then, guys, this will be equal to what? Let's plug in the values that we have. Density is equal to 1 times 10 to the power of 3. Then 1 over 2, we just found V2, which was equal to 2.7 squared, minus 1 over 2. Then V1 is equal to what? V1, we found V1, which was equal to, I think, 0.3. Yes, 0.3. Then this is squared 2. Okay, then we can say plus 9.81 multiplied by 2. Okay, then calculate all of this, and you should get P1 minus P2 2.32 times 10 to the power of 4 Pascal. Okay, this is the final result. If you have any questions regarding this chapter, please feel free to ask me in the comment section. See you in the next video. As soon as possible, I'm going to upload chapter review and assess of this chapter. See you in the next video.